So again, I was based in this book by Charles Platt, Make Electronics, and it teaches me I'm doing this circuit here, which is a voltage fluctuation for the LED there. For the oscillation, only involved with the two transistors, which is this transistor, which is I rated as Q1, and this is Q2, and this is Q3. This Q3 transistor, the third transistor, has no role in the circuit, just to switch on the LED. So this transistor is just to switch on the LED. Okay, what happened here is when the current is switched on, the internal transistor will drop very low, and the emitter and collector will be near the 0 volt, and the base will also low as the emitter for this. When the current is switched off, you can see the internal resistance of the transistor will rise to 5K at least. Means when there is no current involved in the circuit, the internal transistor will be rise to 5K. Means each transistor is its own internal resistance which will involve, and it will rise to the highest list when there is no current involved. There are steps for the oscillation in the circuit. First, the Q1 which involved in the Q1 and 2 which involved in the oscillation. And what is started here is the Q1 switch off and the Q2 is switched on. R1 was grounded with through the Q1 here. And the Q1 of the collector start to rise, and this increases the voltage left side of the C1. This will be increases C1 here based with the Q1 here. Base Q1 also start to rise, but not rapidly, because the R2 which involved here, R2 will has higher value. That take times for the Q1 to start to rise. And when the Q2 is on, the sinking current from R2 pulling the voltage down, and the Q2 is sinking current through the transistor to the negative to the ground. Basically what happening here is the R2 is pulling the voltage through the Q2 when the Q2 is on, and is sinking current through the negative to the ground here, right? As we know, the voltage at the base Q1 increased through the conducting, and the sinking current from the C1 equal drop to the left side, right? All is equal to the left side drop, and what here occur is what is known as displacement current. This actually voltage on C1 is below 0, and immediately switch off, and the Q2 on the base means this will be off when this is below 0. On the C1 is below 0, the Q2 will be off here, and vice versa. There is a mirror image condition which involved here. When this is turned on, this is turned off. When this is turned on, this is turned off, which is the vice versa. It's here is a mirror image, and this is what we call mirror image condition, which is the fluctuation for the voltage in oscillation. Alright, so what here is happen is when the C1 increases, so does voltage on the base on the Q2. Alright, when this is increases, C1 is increases, the base voltage of the Q2 also increases. When the C2 is below 0, then it switches on Q1. So it's like a mirror image what happening here. So Q1, it switches the Q1 off, and by grounding to the base here, alright, it will be ground to the base here, which is switch off here, and the sequence is repeated. Basically what happening in this one is turn on, this is turn off, and this is turn on, this is turn off. It's like vice versa. And what occur is the mirror image, what is involved here. And that's about it, guys. I just want to show the voltage fluctuation for the circuit here.